examples more. Remember, I told you it's essentially the same setup every time. We're kind of getting used to the feel of a mathematical proof. Not because this is something we're going to do a ton of in Calc 1, but because if you go on to take Calc 2 or 3, you'll see it, and it wouldn't be fair if I didn't show it to you. So, on these, we really have the same format every time. Our goal, we're going to write out that definition of a limit. So, if, yeah, you should know it. Come on in. All right, so when we write it out, the absolute value of x minus a, what is
0?
is less than delta. Then the absolute value of f of x. What's f of x?
Cube root x. Is it okay if we put x plus 0? Is that fine?
Yeah.
Okay.
Minus L, what's my limit?
0.
Is less than epsilon. Okay, so that's what we have to show. Is everybody okay with that part? That was the boxed in definition. So step 1 is really like our scratch work. We're going to start with that second part. Absolute value of cube root of x minus 0 is less than epsilon. Did it make more sense to you guys yesterday when I worked it down and kind of kept it as an equation? Okay, cube root of x minus 0 is the cube root of x. All right. What would I do now?
Take out
How do we get rid of a cube root?
cube it.
Cube it. Now, will the absolute value make a difference? Absolute value will make it positive. When you cube it, will that change anything? If you cube a positive, it's still positive, right? So what we're going to do is cube each side. So a cube root of x cubed is just x. It's less than epsilon.
We don't cube.
Sorry, dropped my cube. So x is less than epsilon cubed. Now remember, our whole goal was to try to get it back to this. But isn't this the same as if I said the absolute value of x minus 0?
Mm-hmm.
Yeah, so I really have it. So step 2, I have to tell first what delta is equal to. So my delta is going to be epsilon cubed. And then we rewrite that definition up until the less than epsilon. Okay, we can't write that part yet. So we're going to say, if the absolute value of x minus 0 is less than delta, then the absolute value of my function, which is cube root of x minus my limit, which was 0. And now we work it out. Basically doing the same thing that we were working with before. So, cube root of x minus 0, that's just the cube root of x. Alright. Is it the same if you did the cube root like after the absolute value? Would that be the same? Okay. Because when you do the cube root and then the absolute value, you get a positive number. If you do the absolute value first, you have a positive.
Oh, yes. Okay.
Cube root is still positive. I just rewrote it like that so you could recognize, isn't the absolute value of x same as the absolute value of x minus 0?
Mm-hmm.
And that is less than delta. So this has to be less than the cube root of delta. So I got my less than that I needed. But at the beginning, we said delta was going to be epsilon cubed. So that's equal to the cube root of epsilon cubed, which is epsilon. So I got my less than,
Hang on, what happened there?
and I got my epsilon.
What happened at the end there?
Where?
How do we get the delta back in there at the end?
See, I got confused at the first highlighted piece.
So what I did right there is I said,
I'm okay with the x going
this,
under.
I could think that that's the same thing as saying the absolute value of x is less than delta, right? So right here I have the absolute value of x. If that piece is less than delta, I basically put in my less than delta.
So you plug the x turns into the delta.
Yeah.
Okay.
And it has the less than because x was smaller than that.
And then what is happening? What's the second half?
We said before delta was epsilon cubed. So then I subbed
Oh, gotcha.
my epsilon cubed in for my delta. So that one was a little bit weird because we had that cube and cube root in there. It wasn't just a straight linear one. Other questions here? Alright, let's do another one. So I am trying to prove that this limit is equal to -30. So we write our goal. What is the goal? Minus negative, so plus 30.
Is less than that other thing.
Because it's x minus a, so minus -3 became positive. Alright, so step 1, we have to figure out what delta should equal. So we take that second inequality. And what do we do first?
Add 30.
Okay, so -9 plus 30 is positive 21. Then what would you do?
Take out your 7.
And then what would you do? Okay, so this is what I wanted because I have the x plus 3 and that was an x plus 3. So I know I'm on the right track. So once I have that same absolute value, now I know that delta has to be the epsilon over 7. Do we see that? Is everybody with me here? Okay. So now we do the proof. So the proof, we rewrite that first part of the definition, but we have to first state what delta is. So let delta equal epsilon over 7. If the absolute value of x plus 3 is less than delta, then the absolute value of 7x minus 9 plus 30. And now I have to work this out until I get a less than and an epsilon. So, working it out, we're going to repeat the steps from before. So you add like terms, factor out a positive 7. But I know the absolute value of x plus 3 is less than delta. So 7 times that would have to be less than 7 delta. So now I have my less than that I needed. Now what do we have to get in here? We just need the epsilon. So 7 times, what's delta? Epsilon over 7, which is our epsilon. And that was what we needed to finish it.
So
Is it clicking now?
to get that less than or that less than 7 delta, you just take your. It's always just you're gonna take your delta times that constant.
Mm-hmm.
Okay.
Good.
I'm
Is
looking at
it
this.
clicking, kind of? It will get repetitive over time.
I'm looking at this last thing and I'm kind of confused. But we're
All
not
right.
there yet. I feel so accomplished when I can do it.
So, do we need to do another one?
Yes.
Okay. You guys tell me this time. What is my goal?
If x minus 5 is less than delta.
The absolute value of x minus 5 is less than delta. Then
Absolute value of 17x minus 35 minus 50 is less than epsilon.
okay. What's the first step? We have to figure out. Yeah, we have to find our delta, so we take that second one. So combining like terms, that's 17x minus 85. What can we take out there?
17.
Just as a warning, that didn't happen on any of these, but let's say we'd have like negative 3x minus 9. What can you take out of that?
Oh, 3.
Right. So you would factor it, it's like negative 3 times x plus 3. Do you guys agree with that? When you pull that negative 3 out, what's the absolute value of negative 3?
3.
Positive 3. So if you're factoring out a negative, you have to remember that you do the absolute value, so it's still the positive number that comes out. I think there's one or two on the homework where you have to factor out a negative and it becomes positive.
So I'm still. Okay. But then it doesn't become negative 9 anymore. Doesn't it have to always be. Does the absolute value make that equivalent anywhere?
Yeah.
Okay.
So then here we just divide epsilon over 17. So we're in good shape because we had absolute value of x minus 5, I got the absolute value of x minus 5, so that's what I needed. So step 2, what is the first thing you have to say?
Delta is equals epsilon over 17.
And then what do we do? Write the definition. If the absolute value of x minus 5 is less than delta, then the absolute value of 17x minus 35 minus 50. And now we're going to work this out until we get the less than and the epsilon. Alright, so combine like terms, so 17x minus 85. But what can we take out? And the absolute value of 17 is 17, so that's what comes out. Okay, right here. 17 times the absolute value of x minus 5. And we would have to say less than, because the absolute value of x minus 5 is less than delta. So this has to be less than 17 delta. So I just got my less than in here. You guys with me there?
I think that we have to put this into
Why is it a less than? Oh, because it's just trailing along. All I know is that the absolute value of x minus 5 is less than delta. Okay? So if I want 17 times that, you would have to multiply both sides by 17. So it's 17 delta. Because this side had a 17, so I have to multiply the other side by 17. And then we know our very first sentence of this step, delta is equal to,
Epsilon over 17.
so we get,
So you should always
We
get
got-
epsilon at the
you
end.
should get epsilon at the end. If you didn't, you made a mistake. All right?
How do you say that word? The E word?
Epsilon.
Epsilon. I keep saying it and I slowly start turning into Absalom from Alice in Wonderland.
Okay, so I want you guys to work on this in class so you can ask questions. All right, so you have 6 problems and the rest of class to work on. The last slide, I just kind of put your format, your goal. That's the definition. Step 1, you find your delta. Step 2 is your proof. You restate that first part, work it out until you get the less than the epsilon. So this last slide is just your reminder.